Amco Polymers is a fast, flexible company with an entrepreneurial attitude, backed by the largest polymer distribution company in the world. Amco Polymers was founded in 1955 with a philosophy based on helping customers find solutions to problems and a commitment to continuous improvement in service. From that philosophy, Amco has continued to grow and add diverse services and product offerings, unlike any other plastic supplier in the industry. For more information, please visit our website at www.amcopolymers.com.
Hello, everyone. I'm Joe Pryweller, Conference Director for Plastics News. Welcome to this session of Ask the Expert, your chance to engage with professionals on a range of topics and to interact with questions. Today's Ask the Expert is sponsored by Amco Polymers. Our expert is Mike Walter, Business Director at Amco Polymers. Mike will discuss fundamentals of thermoplastic elastomers and will answer your questions after his presentation. To submit a question, email pnevents@crane.com, or if you're watching along on LinkedIn, Facebook, or YouTube, submit your questions through those platforms. With that, I will turn things over to Mike Walter of Amco Polymers. Mike, the floor is yours.
Thank you, Joe, and good morning, everybody, and thank you for attending our presentation today. We have quite a bit of information to cover, so we're going to dive right in. We'll start with a few general comments. Okay, so a little technical dip to go there. Sorry about that. So first, let's start out with a formal definition of what a thermoplastic elastomer is. So TPEs are low modulus, flexible materials that can be stretched repeatedly at room temperature and return to their approximate original size when stress is released. So all TPEs are extremely versatile. They're used in many applications across all markets, including mobility, agriculture, healthcare, consumer products, sports and recreation, industrial, electrical, electronics, telecommunications, and appliances. All TPEs are easy to process using your conventional plastics equipment that you would use for rigid materials, your typical injection molding machines, blow molding machines, extrusion presses. And certain TPEs can be processed in a blown film equipment. So you might need to make some screw modifications to run certain types of TPEs. For the most part, there's really no capital investment necessary. First, we'll go through a few common traits of all TPEs so that we don't have to keep repeating these when we take a deeper dive into the unique properties of the different specific types of TPEs. So first of all TPEs are recyclable. So that means that you can gather your scrap from your production runs and regrind that scrap and reintroduce it into your process. All TPEs are semi-crystalline as opposed to amorphous. Appearance options offered by TPEs are across the board. We have gloss, matte, clear, translucent, opaque, and all TPEs are easily colorable because they're semi-crystalline in nature. TPEs offer a lot of design, part design freedom, just meaning there's minimal limitations as to what you can and cannot design with TPEs. Some people think because of the softness, you're limited to what you can do. TPEs are pretty versatile from the design standpoint. TPEs make exceptional overmolding materials. They bond extremely well to a variety of substrates, including all the various ETPs and certain commodity resins. They make excellent soft touch type materials. As far as enhancements go, we can add whatever additives and stabilizers you would typically add to a rigid thermoplastic material. Your typical additives would be UV stabilizers, heat stabilizers, flame retardant additives, opacifiers, lubricants, glass fibers, carbon fibers. Those are all compatible with TPE materials. We also have a full line of specialty grades across the portfolio of the different types of TPEs, covering like FDA food contact grades, FDA medical grades, UL listed grades, and NSF approved grades for water type applications. And finally, there is sustainable technology in the pipeline for several of the TPE chemistries. Not ready for prime time yet, but it is forthcoming. Okay, so let's talk about TPE selection attributes. When you set out to choose a material for application, you definitely want to take into consideration the traditional attributes that you would would use for selecting a rigid thermoplastic. That would be your property requirements, chemical exposures, the temperature range in which the part's going to be used, your environmental exposures, regulatory requirements, and also part configuration, process method, and cost. But in addition to that, we also like to take into consideration a few unique properties or attributes relative to TPEs specifically. So first and foremost, hardness, which is the resistance to indenting, is an important feature, okay? And in a TPE industry, we typically talk about TPEs in the form of hardness, but you really have to take into consideration hardness and flex modulus, which is the resistance to bending. We also want to look at toughness. What kind of toughness requirements do you need? Abrasion resistance, cut and tear, and also compression set and sound and vibration dampening are important concepts with TPEs. So we measure hardness using a durometer instrument, and the values that are generated from that instrument are expressed in a Shore value. So the two most common Shore scales used for plastics are Shore A and Shore D. The Shore 00 is also used for very soft materials. I just want to show you this for a frame of reference. So like a typical rubber band has a hardness measurement of approximately 30 Shore A. A tire tread has an approximate hardness measurement of 60 Shore A. And then you move up to more the semi-rigid hardnesses on the D scale, like a hard hat would be a 75 Shore D, just for frame of reference. Now, it's important to understand how TPEs are made before we get into the specific discussions. TPEs are made by combining a hard phase or a hard segment and a soft segment. Each of those segments contributes unique characteristics to the resulting TPE compound. So on the hard segment side, that provides the processing temperatures of the end compound, the continuous and upper use temperatures, the tensile strength, tear strength, chemical and fluid resistance, and your adhesion characteristics. So you're basically your bond strength to the various rigid substrates. Conversely, the soft segments provide the lower service temperature limits, the hardness and flexibility characteristics, and also the compression set and tensile set characteristics, which are very important for TPEs. Now let's take a deeper dive into the specific types of TPEs. We'll talk about 7 of them, 4 primaries and 3 secondaries. The first is a SEBS. It's a styrene ethylene butylene styrene. Its key attributes and applications are as follows. First and foremost, a SEBS is made with a polypropylene hard segment and a SEBS synthetic rubber soft segment. General cost range for SEBS type elastomers are $1.50 to $2.50 a pound. They have a dynamic service temperature of up to about 90 degrees C or 194 F. So they don't make really good high heat materials, but alternatively, they're really used for more room temperature, low temperature applications. They provide a really cool rubbery feel, excellent recovery, outstanding low temperature flexibility. They also bring with them excellent weathering and UV resistance and hydrolytic stability or resistance to moisture. As far as chemical resistance goes, they're resistant to most mild acids, bases, alcohols, and detergents. So they lend themselves to a lot of household item type applications. A very generous hardness range of 5 Shore A to 95 Shore A, so you can get really soft with these SEBS materials. Typical applications would be cell phone covers, medical applications, all sorts of masks and straps, and soft touch overmolds onto surgical devices. Personal care items, that razor you see there, that green color is a 65 Shore A SEBS bonded to a rigid substrate. We have lots of different types of grips and handles, for power tools, hand tools, that sort of thing. And SEBS is also a very popular TPE of choice for exterior automotive applications, seals, primarily window seals. Next, we're going to talk about thermoplastic vulcanizates, or TPVs. They have a polypropylene hard segment and an EPDM rubber soft segment. Not to get too far into the technology here, but basically you're combining polypropylene with an EPDM powder, and during the compounding process, the EPDM basically vulcanizes and becomes fully cross-linked and leads into some very unique properties for a thermoplastic elastomer. General cost range is $2 to $3 a pound. Dynamic service temperature is up to about 130 degrees C or 266 F. That's the value of the cross-linked EPDM rubber, that high heat capability. And in addition to that, you get low compression set values at elevated temperatures. You get good flex fatigue properties at a wide range of temperatures, and just an overall good heat aging properties. Along with it, TPVs have pretty good chemical resistance, mainly to hot oils. TPVs stand up primarily to the non-hydrocarbon-based substances. They also have really good inherent UV resistance. And one unique feature of a TPV is they thrive on shear. So if you're injection molding TPVs, you can use really small pin gates. It just improves your degating, less gate vestige, and of course, overall better cycle times. Hardness range for your TPVs, it's a little less generous than the SEBs, but it's a hardness of 25 Shore A to 50 Shore D. Typical applications for TPVs are across the board, but I'm just showing you here on the screen automotive. As you can see, we won't go through all of them, but it's used extensively in the exterior and the interior of automobiles, all sorts of boots and seals and covers and straps and guards and that sort of thing. So very versatile material. Next on the list is TPO, or thermoplastic polyolefins. They have a polypropylene hard segment and an ethylene propylene rubber or a metallocene soft segment. General cost range is $1.25 to $2 a pound. The main reason why you use TPO is exceptional cold temperature impact. We have grades that are ductile down to as low as minus 50 degrees Celsius. So just an overall excellent combination of impact strength, ductility, and stiffness. They're fully weatherable, and they have excellent scratch and mar resistance, and they're paintable. So your appearance options with TPOs go beyond the normal unpigmented or pigmented options. TPOs are generally more in the semi-rigid range, 90 Shore A to about 60 Shore D. Applications are just a variety of bumpers and fascia. We have pictures here of a green tractor fender. I'm sure you can surmise who that goes to, but there's also used quite a bit on ATV vehicles and just all sorts of bumpers. So let's talk about TPU. I think it's the most versatile TPE of all the TPEs. So in understanding TPUs, first there's two basic families of TPU, and then within those families, there's two basic types of TPU. So there's aromatic and aliphatic TPU, and within those, there are polyester and polyether types. So the hard segments would be the aromatic or aliphatic diisocyanate, and the soft segments would be the polyester or the polyether polyol. The aromatics are pretty much the workhorse for most applications. They provide the best balance of all properties. The aliphatic grades are light stable grades. If you need long-term color stability with non-yellowing features and optical clarity, aliphatics is the way to go. General cost range, esters are around $2.20 a pound up to $4. Ethers around $2.75 to $5. And just in case you're curious, the aliphatics are north of $7. So I know cost does play a role. So you pay dearly for those unique features. The hallmark of TPU is just its excellent balance of mechanical properties and toughness. It has outstanding abrasion resistance, excellent cut and tear resistance, tremendous burst strength for like pneumatic tubing, for instance, and great scratch and mar resistance. It has excellent sound and vibration dampening. It's probably the material of choice for any kind of dampening application. And along with these properties, along for the ride comes good compression set, which can be improved by post-curing, by the way, especially at the high temperatures. Good chemical resistance, just an overall balance of good chemical resistance. TPUs have a broad end use temperature range, just depending on which grade you're choosing. And one key note about outdoor applications, if you're using TPU in an outdoor application, the polyether is the way to go. They have excellent hydrolytic stability or resistance to moisture, excellent fungus and resistance, and cold temperature flexibility. The hardness range for TPUs are in the 60 Shore A up to about 80 Shore D. Typical applications for TPU are across across the board. They're used everywhere, but just wanted to show you some more unique applications. A blow molded soft terrain vehicle tire, very punishing environment, usually on beaches and construction sites. Dental ligatures for those who have kids or those who have had braces, you know what these are. That's a nasty environment. Caster wheels for a lot of material handling, very heavy loads, racking systems. Pet chewy toys. I know during COVID, these were hot sellers, so I thought I'd showcase that. My favorite is the geophysical cables. These have TPU jackets on them, and they reside at the bottom of the oceans for months on end. Animal ID tags, raising cattle and pigs, all sorts of extruded tubing and belting, and athletic shoe soles. Finally, we have one quick slide to cover the last three more specialty type TPEs. First of all, a copolyester. It's a polyester hard segment with a polyether soft segment, just like the one used for polyether TPUs. General cost range is $4 to $6. The reason why I use COPE is it has excellent flex fatigue resistance over a broad temperature range. Overall hardness range is 30D to 80D, not as generous as the TPEs. But as you can see, I'm showcasing here a picture of a constant velocity joint boot and where it's installed on a vehicle. These CVJ boots basically see extremely harsh environments, and COPE stands up to them. That's really the big application for COPE. PIBA is a nylon elastomer or a polyamide elastomer. And the soft segment is the same polyether used in polyether TPU. Price range is climbing up there to the $5 to $8 mark. The big thing about PIBA, it really offers a lot of the same features as a TPU or a COPE, but it has a lower density, so you can make lighter weight parts. And also because of the nylon substrate, you have a much lower coefficient of friction, so you have a much smoother surface. PIBAs are just outstanding materials. They offer excellent resilience, hysteresis, flex fatigue resistance, kink resistance, over a wide variety of temperatures. PIBAs lend themselves to all sorts of medical devices, especially slide and groove type applications because of the low coefficient of friction. And ski boots. A lot of professional skiers really prefer ski boots made out of PIBA versus a copolyester or a TPU. All are very common ski boot materials. And finally, last but not least, a very specialized material called melt processable rubber. It's kind of a modification of a COPE. It's a COPE hard segment and a chlorinated ethylene soft segment. Price range is about $4 to $7. Its unique features are low squeak for a thermoplastic, which is unique, and it has really good fuel resistance, which most other TPEs do not. And along with that, it has good weathering, and it's flexible over a wide range of temperature. But the most notorious MPR application is a vapor recovery nozzle, which you see every day at the gas pump. That little cup there contains the vapor in your fueling channel. So there you have it. Thank you very much for listening, and now we can take whatever questions you might have.
Thanks, Mike. Terrific presentation. Learned a lot about all the different variants of TPEs that are out there and what they're used for. Again, if you'd like to submit a question, you can ask your questions by sending them to pnevents@crane.com, or if you're watching along via LinkedIn, YouTube, or Facebook, you can send your questions along via those social media platforms, and we'll get to the questions in the order that they are received. Mike, first question for you. What's the difference between a TPE and TPR, thermoplastic rubber?
Very good question. Haven't heard TPR in a while. TPR, basically TPEs and TPRs are the same thing, okay? Essentially, years ago when SEBs and TPVs were developed, they kind of marketed them as a TPR to transition between using a traditional thermoset rubber to a thermoplastic system. So it was probably more of just a marketing, continuity feature. Over time, the key buzz phrase is thermoplastic elastomer. So basically the same thing, but TPR is really referenced the SEBs type products and the TPV type products.
Okay. Are there advantages of TP versus natural rubber, or when was one better used? That's one better than the other?
Sure. Well, the just referencing back to some of the things we talked about, TPEs, thermoplastic elastomers, are much easier to process because of their thermoplastic nature. They don't cross-link or become fully vulcanized as a material. So TPEs generally offer better lower temperature properties and usually better flex fatigue type properties. Rubber products would really be more of a natural rubber. Different types of rubber offer very low squeak, very low compression set because they're fully cross-linked, and they're preferred for the much higher heat environment applications.
Excellent. Are there issues with toxicity with TPEs, or what level of toxicity do TPEs you generally have?
Another good question. So basically, all TPEs are relatively clean. Okay, they have low emissions. Like the melt processable rubber, I would not classify as a low toxicity type material, but really the SEBs, the TPVs, TPUs, COPEs, and PIBAs, those categories have full medical grade product lines that have been fully tested under ISO 10993 and USP Class 6, which is basically a subset of ISO 10993. So yeah, low emissions and very clean products.
Excellent. You mentioned there's different processing means that you can use for TPEs. I guess first question I have there is blown film used that much? You mentioned it can be used in various applications without any added expense, but are you seeing blown film as much as you are with some of the other processing means that are out there?
Very good question. Blown film is somewhat of a micro industry, but it's a large industry. It's very large. It's not nearly as big as your traditional injection molding and extrusion or even blow molding, but blown film, is a really big TPU process and application. So there's a lot of really thin laminates, thin films that are made through this blown film process and used in a variety of applications, from clothing, textiles, to automotive, all sorts of applications.
Great. Here's a question that came in from LinkedIn, viewer on LinkedIn. Is it possible to add fillers to TPUs and to make it electrically conductive?
Yes, it is. So TPUs are very receptive to carbon fibers or other types of carbon black, conductive carbon black materials. Carbon fibers, if you have the proper equipment to handle them, they're probably the best. They provide the highest level of conductivity. And like I said, if you have the proper equipment, they're fairly straightforward to handle. There's a lot of different types of conductive carbon black in powder form, which gets a little messy. So a lot of compounders steer away from using conductive carbon black, but yeah, it can be done. It's done quite a bit. And just as a side note, we talked about PIBA. PIBA is by its very nature is permanently anti-static, and it is used to modify TPU and other materials for permanent anti-static features. So just something to keep in the back of your head.
Great. Here's a question that just came in. Which TPE has most issues, I guess, with environmental pollution or health hazards? Are there issues with those with some TPEs?
No, that there's really no TPEs and all plastics once they take their a solid form, really there's unless you incinerate them, there's really no bad environmental effects. I mean, obviously we with sustainability being a hot topic, we want to keep plastic articles out of the ocean. We want to do the right things to channel scrap plastic in the designated directions, to make sure that they're not harmful. But no, there's as far as emissions or or pollution of that sort. It would just, as long as you keep the hard plastic products out of the places where they don't belong, we're good.
Good. Let me ask you as a sort of a maybe an addendum to that question. You mentioned there's some sustainable technologies that are coming around the horizon. Can you clarify a little bit about what might be coming or what might be looked at?
Sure. Well, the big one is polyurethane. Covestro and BASF and a few other of the large major TPU producers are working on sustainable sources to make the diisocyanates and the polyols. As I mentioned, it's really not ready for prime time. There's a lot of R&D that goes into doing this, but in other products like polycarbonate and other more rigid materials, I think they're further along in the technology. But TPU and other elastomers a little trickier to try to figure out how to make these raw materials and have some semblance of the physical property profiles that traditional TPUs and copolyesters and PIVAs provide. So
are you talking about using recycled materials in this case, the difficulty?
No, this would not be recycled. This would be, for instance, with TPU, they're actually trying to develop the hard segments and the soft segments in a sustainable green fashion.
I see.
Try to mimic the same types of properties. So yeah, with green, you have recycling and reuse of regrind and that sort of thing, and then you have sustainable sources of raw materials, and that's really what I'm referring to with the TPU.
Okay, great. Here's a question: are there any efforts to create biodegradable TPEs like PEAT, soft segment, or something along those lines?
That is being looked at. That's another good one. Yeah, so they are being looked at. There's a ways to go. Biodegradable plastics, is a difficult topic. They're expensive. Biodegradation systems, tanks and enzymes and all these things that have to be used along with it. You can't just, you gotta. There's a lot of things to take into consideration. I would say that there is R&D efforts, I know, in the TPU industry, but it's not as far along as the sustainability efforts.
Okay, great. Yeah, that's a topic that's been discussed for a long time, but not always able to put into action. The other question that came in through pnevents@crane.com: can you give more insights on recyclability of TPEs? Can they be recyclable?
Yes. So all TPEs can be recyclable. I'm pretty sure they're in the other category with the recycling codes, but everything, including the TPVs, are the closest thing to a cross-linked vulcanizate type product, and even the TPVs can be recycled. So really, no matter what TPE you're using and no matter what process, those materials can be ground up and reused in your process. They can be sold off into what we call secondary markets, to compounders that use those feedstocks to create what we call reprocessed materials that just prolong the life of that original plastic pellet. So yeah, it's definitely doable.
I asked a question. I'm curious, as you talked about all the applications for the different types of TPEs that are out there, are you seeing anything that's new and emerging that's exciting that might be on the horizon or coming as far as TPE applications go?
Well,
I hate to put you on the spot here, but
yeah, no, that's a loaded question. There's a lot of obviously polymer producers have extensive R&D units because you have to constantly be looking at applications 2 years down the road and 5 years down the road to make sure you have products capable of handling those applications. So yeah, there's always a wide variety of things in the pipeline. Unfortunately, like these producers also keep a lot of these applications close to the vest because until they figure it out and know how to skin the cat, they don't want to give anybody else a running head start. But there's just been a lot of there's been so much technology over the years, in medical and automotive. There's just a lot of examples, but there are some new projects coming down the pike. But I better keep that one close to the vest for now.
Okay, that sounds good. Well, stay tuned. More to come. Are TPEs in short supply? Question from our audience.
Oh gosh, supply issues. Okay, yeah, that's a great question. So, as we all know, our world is upside down right now with supply, and basically the vast majority of rigid thermoplastics are in tight supply, force majeures, but with TPEs, as far as so TPU, for instance, is in very tight supply. And that's because, and so is copolyester and PEBA, because the polyether soft segment, basically 50% of the capacity to produce the polyether soft segment named PTMEG was confiscated by the government, basically to use in the production of the COVID-19 vaccine vial caps. So a worthy cause, okay? So, but that's really put polyether-based TPUs in very tight supply through probably the end of the third quarter. TPVs and SEBS-based materials, they are not nearly as in tight supply as TPU, but the only issue right now is the availability of the polypropylene. The oil extended EPDM rubber used to make TPVs and the SEBS synthetic rubber materials, they are tight, but not nearly as tight as as some of the other products out there.
Yeah, it sounds like it. I like medical applications, especially. That's where you find short supply, right?
Yeah, usually, what we've found is most producers, have been really good stewards, through this force majeure process. Most producers have, medical grades targeted for COVID or other critical medical applications. They've tried to keep as much material flow, in the pipeline filled as possible to these OEMs and processors who use these materials. So I'd say the medical world is in better shape than most, but the medical world is looking for material. No
Definitely. Question. Well, Mike, we're running out of time. I should ask you if you have any final parting thoughts that you want to leave the audience with and want to share.
Oh, just thank you very much for listening. This was a lot of fun. And, Joe's going to show my email at the end of the presentation. So I encourage you, if you want a copy of my presentation, if you want a copy of a more detailed presentation, we only had 15 minutes today to present. So I've got presentations spanning, 60 to 90 minutes. If you need anything like that, I've got those tools I can send to you. And if you have other, more specific questions that we can handle offline, I'm happy to talk to you.
Great. Mike's email address just popped up on the screen for anybody who wants to reach out for a more extended presentation, or if you have any questions that you want Mike to go through, or any projects you want to discuss. Again, I want to thank Mike Walter of Amco Polymers for a great presentation and really condensing, which could probably be hours of fundamentals of TPEs into 15 or 20 minutes. So that was great. And I want to thank Amco Polymers for sponsoring this Ask the Expert session today also. And again, you can reach out to him directly if you want more information. Today's Ask the Expert session will be available for viewing on the events site of Plastics News webpage. I'm Joe Pryweller with Plastics News. I'll see you at a future Ask the Expert session. We'll end with a brief message from Amco Polymers.
Amco Polymers is a fast, flexible company with an entrepreneurial attitude, backed by the largest polymer distribution company in the world. Amco Polymers was founded in 1955 with a philosophy based on helping customers find solutions to problems and a commitment to continuous improvement in service. From that philosophy, Amco has continued to grow and add diverse services and product offerings, unlike any other plastic supplier in the industry. For more information, please visit our website at www.amcopolymers.com.